Dear friends, welcome to DIY Embedded Tutorials. Today we will learn how to interface DS1307 RTC module with Arduino board. We all know that most microcontrollers we use for our projects are time agnostic. They are unaware of the time around them. Most of our projects works without time information. But in a situation when your microcontroller must need timekeeping, RTC modules like DS1307 is unavailable. It is perfect choice for projects containing clock building, data logging, timers, and alarms. So let's see how to use RTC modules with Arduino boards. By completing this tutorial we will learn these things. First of all we will see different features of RTC module. Secondly we will check the pinout of module. Next, we will connect our DS1307 RTC module with Arduino UNO. Next we will check available Arduino library to interface RTC module with Arduino UNO or any Arduino board. Finally we will end up by writing code in C to read date and time from RTC module. So let's start with exploring different features of RTC module. At the heart of the module is a low-cost but quite accurate RTC chip from Maxim DS1307. It is responsible for all timekeeping functions and features a simple 2-wire I2C interface, with which it can be easily interfaced with any microcontroller of your choice. The chip maintains seconds, minutes, hours, day, date, month, and year information. The date at the end of the month is automatically adjusted for months, with fewer than 31 days, including corrections for leap year. Valid up to 2100. The clock operates in either the 24-hour or 12-hour format, with an AM/PM indicator. The other cool feature of this board comes with SQW pin, which outputs one of 4 square wave frequencies 1 Hz, 4 kHz, 8 kHz or 32 kHz, and can be enabled programmatically. Note DS1307 come with an external 32 kHz crystal for time calculation. The problem with these external crystals is that temperature can affect their oscillation frequency. This change in frequency is negligible, but it surely adds up. It actually results with the clock being off by around 5 or so minutes per month. Another important feature is battery backup. The DS1307 incorporates a battery input and maintains accurate timekeeping when main power to the module is not available. The built-in power sensor kit continuously monitors the status of VCC to detect power failures and automatically switches to the backup supply. So, you need not to worry about power outages, your microcontroller can still keep track of time. The bottom side of the board holds a battery holder for 20mm, 3V lithium coin cells. Any CR2032 battery can fit well. Please note, assuming a fully charged CR2032 battery with capacity 47 mAh is used, and chip consumes minimum of 300 nanoampere, the battery can keep the RTC running for a minimum of around 17 years, without an external 5-volt power supply. This RTC module also comes with a 32-bytes 24C32 EEPROM chip from Atmel, having limited read-write cycles. It can be used to save settings or really anything. The 24C32 EEPROM uses I2C interface for communication and shares the same I2C bus as DS1307. There is also a hidden feature in module. There's a provision on our DS1307 RTC module that often goes unnoticed. It allows us to install DS18B20 temperature sensor. The 3 holes in the top corner right next to the battery HOLDER, labeled as U1, is where the DS18B20 is installed. Once you install the DS18B20, you will be able to get temperature readings from DS pin. These readings can further be used to compensate for temperature-based time drift in code. Follow the silk screen to solder DS18B20. You might also need a 4.7K resistor between VCC and DS. Now let's examine the pins of DS1307 RTC module. Module has 7 pins in total that interface it to the outside world. SQ pin. It outputs one of 4 square wave frequencies 1 Hz, 4 kHz, 8 kHz or 32 kHz, and can be enabled programmatically. DS pin. is supposed output temperature readings if your module has a DS18B20 temperature sensor installed right next to the battery holder labeled as U1 SCL pin. It is the clock input for the I2C interface and is used to synchronize data movement on the serial interface. SDA pin is the data input-output for the I2C serial interface. VCC pin. It supplies power for the module. It can be anywhere between 3.3 V to 5.5 volts. Ground pin. It is a ground pin. BAT pin. It is a backup supply input for any standard 3V lithium cell or other energy source to maintain accurate timekeeping when main power to the device is interrupted. Wiring DS1307 RTC module to Arduino UNO. Now let's connect the RTC module to the Arduino UNO. Connections are fairly simple. First, connect VCC pin of RTC module to the 5V output on the Arduino UNO. Second, connect ground of RTC module to ground pin of UNO. Now remaining are I2C communication pins, that is SCL and SDA. Please note that each Arduino board has different I2C pins, which should be connected accordingly. On the Arduino boards with the R3 layout, the SDA, data line, and SCL, clock line, are on the pin headers, close to the analog reference pin. They are also known as A5, SCL, and A4, SDA. Installing RTClib library. Communicating with the RTC module over I2C is a bunch of work. But fortunately, we have several open source libraries ready to use. These libraries provide simple commands to read time information from RTC module. In our tutorial we will use RTC library developed by glabs.org, which can be downloaded from this GitHub link. To install this library in Arduino software, navigate to the menu Sketch, Include Library, Manage Libraries. Wait for Library Manager to download libraries index and update list of installed libraries. Filter your search by typing RTClib. There should be a couple of entries. Look for RTClib by Adafruit. Click on that entry, and then select Install. Now we have everything ready to start code to interface RTC module. Let's start coding. We need two header file, wire.h and rtclib.h for communicating with the module. We then create an object of RTClib library. Now in setup function, call begin function of this RTClib object to ensures that the RTC module is connected. Is running function reads the DS1307's internal I2C registers to check if the chip has lost track of time. If the function returns false, this means RTC is not keeping time. We can then start RTC by setting the date and time. To set RTC time we have function named adjust. This is an overloaded function. In our case we call this function with date time as parameter. Here we are passing compile date and compile time to be set as current date and time of RTC. We can also set the RTC with an explicit date and time like this. Now we are done with setting up our RTC. RTC is now started keeping time, even if we remove power of Arduino board. Let's start reading time information from RTC. For this we have function called now. This returns current date and time. Its return value is usually stored in the variable of data type date time. You can use different function like year, month, minute etc. to get different time units explicitly. In this example we are reading current time stamp every 2 seconds, and then printing it in different format.